Rain, fantastic if you can get it in the summer. Of course it all falls in the winter, so why not try and save it? Of course I'm talking about water retention. Good morning and welcome to Miranda Energy Park. It's 29th of June, middle of winter. It's cold. Today we're going to talk about swales, large and small. I've got two swale systems to show you. One's a small one with Hugelkultur mounds, the other one's a much bigger one on deeper land. It consists of 3 swales. So, I hope you learned something. This clip shows runoff, which you could otherwise have directed to a swale, and then it would hydrate a landscape. Swales are ditches dug on contour, as this model shows. So when it rains or they fill from a pond overflow, they flood evenly because they're on contour. Then they've reached the sill level and they overflow. This is the Hugelkultur bed project. Swales, these little swales that were dug 2 years ago now. They're shallow and they're small, but they're on contour. And there's this top one here, which is kind of quite hard to see because I've just cut the grass. And then there's this lower one here, and one feeds into the other over a level sill, which is underneath this pile of grass. Now, just for a bit of perspective, these two little swales we're looking at, this graphic shows where they are on the property relative to the main pond. So here's the swale system, the small one in development. There's the logs, form the first Hugelkultur mound. Then you put some dirt on top. Then you spread the dirt out. Put a whole lot of sticks and bits of log and what have you. Bit more dirt and spread it out, make it nice and even. So this is what it looks like 6 months later in the middle of the summer. That Hugelkultur mound is covered in nice young tamarillos, and I have never manually watered those. They're relying entirely on whatever moisture was soaked into that mound and the logs in that Hugelkultur mound over the course of the last winter. Water flows down this little valley. There's a tiny wee little mini gorge in there amongst those trees. It's the overflow from the main water supply on the property, a pond at the very top, and it comes down here. That peg indicates the start of a pipe. It just goes into a pipe, most of it comes out here, the other end into the top swale, and from the top swale it soaks into the Hugelkultur mound. So the water in this top swale soaks in. At the other end it overflows onto the level sill and flows down into the bottom swale, and from the bottom swale it overflows into the wetland just over the ground. But that is a Hugelkultur mound full of old logs and sticks and what have you. Second one to be built below it when it dries out, using that topsoil over there. So there you have it, close to the shortest day in June 2021 in the southern hemisphere. There you go. So let's get back to our model. This is how it works. Swale fills with water and it soaks into the ground and forms this lens of moisture underground, and then when the swale fills again, the lens just gets bigger until it reaches an impervious layer, and then it just travels downhill slowly. This is what happens to water that ends up running off the property. Now that could have been saved in a swale and used to hydrate a landscape. And this graphic just shows the other swale system on the property. This is a much bigger one. And this is the middle ditch of 3 after the earthworks, and then this one shows it flooded after the first rain. Bit of rain last night, a lot of rain last night. And up the far end of the same swale, the bottom swale, it is right on the point of overflowing. And you can see it's flowing down this level sill into the wetland. So this is the other end of the middle swale with its berm and its fruit trees sitting on top of the berm. This is the top swale. So all 3 swales are full of water.